Hello, Namaste, Konnichiwa, welcome to Sunny Sensei. In this lesson, we will prove the converse of the midpoint theorem. If a line through the midpoint of one side of a triangle is drawn parallel to another side, then it bisects the third side. So, what do we have? First, we have a triangle ABC with D as midpoint of side AB. AD equals DB. Second, we have DE such that DE is parallel to BC. We need to prove that point E bisects side AC or AE equals EC. Now let's move to the proof. We start with triangles ADE and ABC. Angle DAE equals angle BAC. This angle is common to both the triangles. This is equation number 1. Next, we have DE parallel to BC and AB is transversal to these parallel lines. So, angle ADE equals angle ABC. Why? These are corresponding angles, and corresponding angles are equal. This is our equation number 2. With two pairs of equal corresponding angles by the AA criterion for similarity, triangle ADE is similar to triangle ABC. Now, for similar triangles, the ratio of corresponding sides is constant. This means that ratio of AB to AD equals the ratio of AC to AE. Going ahead, we can replace AB with AD plus DB and AC with AE plus EC. Now, DB equals AD. So, we replace DB with AD and get AD plus AD over AD equals AE plus EC over AE. Or 2AD over AD equals AE plus EC over AE. Cancelling out AD from numerator and denominator, we get 2AE equals AE plus EC or AE equals EC. With this, we have proven the converse of midpoint theorem. If you enjoyed this lesson, don't forget to like, share and subscribe to Sunny Sensei. Thank you and see you again soon.